Okay, 1.1, we are writing trigonometric ratios. So sometimes, most of the time, we just say trig. But trigonometry is using these ratios. Today we're going to learn sine, cosine, and tangent. So when you look at a right triangle, we have these, we label the sides, and that's how we get those into our trig ratios. So first thing, a reference angle. This is the angle that we are focused on, that we have picked. It determines the sides. All right, adjacent side. Adjacent actually means next to. Like if I'm adjacent to you, I'm next to you. So it's the side next to the angle. And then opposite, same thing. If I'm sitting opposite you, I'm sitting across from you. So the opposite side is across. We would say it's the side across from the reference angle. And also up here, I'm going to change that to the reference angle. We're focused on the reference angle. So when we have a right triangle, we always label the hypotenuse. It's the one across from the right angle. That one is true. We know that one. But right here, theta, that's our reference angle. That's the angle we're focusing on. Across from that is the opposite side of the triangle. And then next to it is the adjacent side. So once you have those labeled, we're going to find the sine ratio, the cosine ratio, and the tangent ratio. We shorten them when we write them out. We write SIN for sine, COS for cosine, and TAN for tangent. But when we're reading these, you always say the full word. You always say sine, cosine, tangent, not sin, cos, tan. Don't say that. That's wrong. We never shorten it when we're reading it. So a way to remember sine, cosine, tangent is this part. This is just a memory thing. We say SOHCAHTOA. It's just a way to remember that the sine is the ratio of the opposite and the hypotenuse. And that cosine is just the ratio of the adjacent over hypotenuse. And tangent is just the ratio of opposite over adjacent. So when we write these, x is the reference angle. Whatever's next to sine, cosine, tangent is the reference angle. So this would be our reference angle if I want to write these ratios. So always label the sides. Across from the right angle is the hypotenuse. Across from our reference angle is the opposite. And then I always do adjacent last. It's the one next to the angle. And then remember, these are just ratios. They're just a fraction. Sine is opposite over hypotenuse. So 16 over 20. And then those both divide by 4, so it'd reduce to 4/5. Cosine of reference angle x is adjacent over hypotenuse. So 12 over 20. Those also divide by 4 to get 3/5. And then tangent is opposite over adjacent. So 16 over 12. Again, I'm going to divide by 4 and get 4/3. And then our reference angle can switch. Because our reference angle can never be the right angle. So you have two options on your reference angle. So now if our reference angle Z, across from that is now the opposite. And then next to that is now the adjacent. But the hypotenuse, that stays the same. So now our ratios are going to change because our sides have changed. So sine opposite over hypotenuse is now 12 over 20. Those both divide by 4 to be 3/5. Cosine is adjacent over hypotenuse, which is 16 over 20. That reduces to 4/5. And then tangent is opposite over adjacent, which is 12 over 16. And that reduces to 3/4. So I want you to notice something, and this happens every time. When you switch the reference angles, cosine and sine switch spots. See here, sine of one reference angle is the cosine of this next reference angle. Cosine of our first reference angle is now sine of the second reference angle. And because those opposite and adjacent switch, and that's all that tangent is, the tangent values are the reciprocal. The fraction went from 4/3 to 3/4. So this happens every time with our ratios. So if you find the ratios for one reference angle, you know the ratios for the second reference angle. So in this section, we're just going to write the ratios, label the sides, get used to these, and then in the next section, we will use these to solve.